All right, so we're going to look today at multiplying and dividing radical expressions. We already did a section on multiplying and dividing just monomials, but these are going to be work with two terms, or we call them binomials, okay? The rules, there are really no new rules other than just applying some of the older stuff to some things that look a little different, okay? So the first example here, we're asked to simplify, and we're going to do that by distributing. So 3 times 2 is 6. 3 times 4 root 5. When you multiply those two, you're only going to multiply the 3 with the 4, and you get 12, and you leave the root 5 alone. And then 2 root 5 times 2, you're only going to multiply the 2 with the 2, you get 4 root 5. And then the last part here, when you go 2 root 5 times 4 root 5, you're going to multiply the 2 with the 4. The parts that are outside the square root, you get 8. And then square root of 5 times the square root of 5, which is the square root of, you could write 25, or if you want, you could write 5 times 5. But it does change. Don't just leave it a 5. And so we can take the square root of the last one. And then you simplify. You look for things that are alike. The 12 root 5 and the 4 root 5, we can add them because they both have a root 5. And you end up with 12 plus 4, which is 16 root 5. And remember, when you add, you don't change that square root. We still have the 6 out front. And then we have the 8 times 5, because the square root of 5 times 5 is 5. So 8 times 5 is 40. We can add the 40 and the 6, and you end up with 46 plus 16 root 5. And then one more step, what can we do? Add the 46 and 16 is very tempting, but we can't. Okay, because order of operations says we have to multiply the 16 and the root 5 first, but we can't do that without a calculator, so we need to stop there. Okay, so I was being tricky by saying one more step. Okay. That's where we got to stop. Okay, so this next one, square root of 7 plus square root of 3 squared. Well, what's the square root of 7 squared? And what's the square root of 3 squared? So 10, right? No, don't do that. Don't do that. Okay? Why can't I do that? Why can't I do that? It's tempting to do that. What did I do wrong, guys? Okay, what is it? When you have more than one term, or in parentheses squared, you need to rewrite it as what? You write it as 2 of them, sure. Squared means you're multiplying it with itself. So this means the square root of 7 plus square root of 3 times another square root of 7 plus the square root of 3. So you have to rewrite it that way first, otherwise you'll end up with the wrong answer, okay? And then you go through the distributing. Square root of 7 times square root of 7, the square root of 49, or you could say square root of 7 times 7, which we will end up getting 7 from that. So that wasn't wrong to say. But what we didn't do is the square root of 7 times the square root of 3, which is the square root of 21. And we got another one, square root of 3 times the square root of 7. And lastly, square root of 3 times the square root of 3, which is 3. So we can add those two middle ones. What's the square root of 21 plus the square root of 21? Square root of 42? No. What is it? Square root of 21 plus the square root of 21. No. When you add to, how do you how do you add to radicals? What do you have to add? Do you add the radical part? No, what do you add? The numbers in front of them, right? So there's an invisible 1 here, and there's an invisible 1 here. So you add 1 plus 1, and you get 2. So 2 root 21. Okay. And then 7 plus 3 is 10. And then one more step, or no? No. Stop there. Okay. Where'd the 3 go? 7 plus 3 is 10. Okay. Okay, so the next two are like that. So take a minute and try the next two. Isaiah, can you tell me how you started multiplying this one together? Okay, so when you did that, what'd you get for 3 root 7 times 2 root 7? Okay, so we're going to multiply those together. And so you end up with 6 times 7. Good. And then when you multiplied 3 root 7 times the negative root x, what'd you get? Good. Good. And then what'd you do? And what'd you get? Okay. And so this becomes plus x. And then the middle two terms are like terms, so we can add them or subtract them. So negative 3, negative 2 gives you negative 5, square root 7x. And 6 times 7 is 42. So we have 42 minus 5 root 7x plus x. Is there anything else we can do? Do we need an absolute value around the x? Or not? Well, let's put it this way. Does x have to be positive? Or does this expression, when you take the square root of x times x, do we need a positive answer? Yes, when you take the square root of anything and you get that out, you have to have a positive answer. So then the question is, do we know that x is positive? And so there's a couple ways we can look. First, we look at the instructions and say, well, does it say that the variables represent positive numbers? It does. It says assume all variables represent positive real numbers. And so because of that piece right there, we could say, yeah, we don't need an absolute value because we already know x is positive. We could put absolute value around that, but that's just being redundant, right? Saying make what's positive positive, well, it already is, right? So is there anything else though we can do besides that? Okay, that's what our answer looks like. All right, and then the next part, square root of 30 minus square root 3 times square root 6 plus the square root 5. Braden, lead us through that one. Okay. Okay, what do you get? Just do 30 times 6. Good idea. Good idea. Okay, keep going. Like this. Okay. Okay. And then is that where we stop, or did you do anything else there, Braden? Okay. So how would you break it down? Okay. So the first part becomes 6 root 5. That's good. So the next one is 5 root 6. Can't do anything with that one. Okay, now what? Can't do anything? That's where you stop. That's good, because that's where I would stop too. Okay, good job. Okay, so that's what our answer looks like. We can't simplify this any further because nothing. You can't take the square root of anything else, and none of the square roots match. Okay. All right. So sometimes a denominator is a sum or difference involving radicals. If the radical expressions are square roots, you can rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. And if you remember, even in part of your homework or the part of the notes, the last part of the notes from Friday, we started talking about what a conjugate was. And we said when you multiply conjugates together, you end up getting rid of square roots. So if you go back to our second lesson, we talked about the importance of, or what it means to rationalize the denominator. It means we got to get rid of all square roots. If there's a square root and the denominator is not rational, we need to get rid of that, make it an integer, which is a rational number. Okay. So 7 minus square root 10 is irrational. Any idea what you might want to multiply that by to make it rational? Square root 10? Let's try it. So if we multiply the top and the bottom by square root 10, we end up with 3 square root 10. Is that okay that the numerator is not rational? Yeah. And then you got to distribute the root 10 to both of these, right? So you end up with 7 root 10 minus root 10 times 10. We're going the direction we want. Still going to have that 7 root 10. We'll get rid of this square root, right? This will become just a 10, but we'll be stuck with the 7 root 10. And it's not going to... You can multiply by square root 10 again, and they'll just keep going in circles here, right? Won't go anywhere. All right, maybe you need to read this part again that's above. And it kind of tells you what to do. It tells you what to multiply by. Okay, what does it say, guys? Multiply the numerator and the denominator by the conjugate of the denominator. Okay, so our denominator is 7 minus square root 10. What's the conjugate of the denominator? 7 plus square root 10. So a conjugate is kind of the opposite, not exactly the opposite. It matches the two terms, but in between them, you're going to put the opposite sign. Yeah. That's what we mean by conjugate. So here we got another 7 plus square root of 10. Why do I have to put that in the multiplying the top part as well? So that this whole thing equals 1. All we're doing is multiplying by 1. Okay. So if we multiply this out, hopefully it works. So let's see, 3 times 7 is 21. 3 times square root of 10 is 3 times square root of 10. 7 times 7 is 49. 7 times square root of 10. Negative square root of 10 times 7. And lastly, negative square root of 10 times positive square root of 10. It still looks like a mess. Gonna work out though? Yeah, because the 7 root 10 minus 7 root 10 adds up to 0. We got a 49 here, and then the square root of 10 times square root of 10 is just going to be 10. And so we can clean this up more. 21 plus 3 root 10 over 49 minus 10. And now our denominator is a rational number. It's an integer, which can be expressed as a fraction of two integers. Okay. Can we simplify any further? Or are we done? We can. So when you're looking to simplify a fraction, you're looking only at these places here. The 2, the 3, the 39. And you're asking, hey, can I divide all those by something? In this case, we can divide them all by 3. When we do that, we end up with 7 plus 1 root 10 over 13. Divided those by 3. Okay? So we need the conjugate when the denominator has a plus sign or a minus sign in it, and there's two terms, and you got a square root in at least in one of those terms. Okay, that's what you're looking for. So in this second fraction here, what might we want to multiply by? Square root of 3 minus square root of 5. Go ahead and do that. Simplify it as much as you can. Get to an answer. Okay, Jaren left. Okay, so Sierra, what'd you get when you multiplied root 7 times root 3 minus root 5? So root 21, so going 7 times 3 minus root 35. Okay, and can you subtract those, or do you have to leave that like that? Just leave it like that, good. And what'd you get when you multiplied root 3 plus root 5 times root 3 minus root 5? Okay, so 3 because it's square root of 3 times 3 minus root 15. So that's coming from the product of these two. And then minus what? Root 5 times 5? Sure. Okay. And because we're multiplying these two together. Perfect. And then we can simplify those. The two middle terms add up to 0. And then we're going to leave root 21 minus root 35 alone in the numerator. And this becomes a 3 minus 5. 3 minus 5 is negative 2. Is there anything else we can do to this? Okay, so we'll just leave it. Oops. Leave it as is. That's our answer. Okay, try the next one. Okay, I know. What did you decide to? How did you simplify this? What did you do first? Good. So this is what the conjugate looks like now in this case. 2 plus 5 square root 8. You copy everything as is from the denominator, but change the sign in between. If we have a minus sign in between the 2 and the 5, put a plus sign there. Okay, good. And so when you did that, after you did that, what'd you get through multiplying the numerators together? Good. So this is a good way to start. You get four products. You're 3 times 2, 3 times 5, root 8, root 8 times 2, and root 8 times 5, root 8. And so that's, I mean, it's not simplified yet, but that's how you start. And we can do the same kind of thing to the denominator. 2 times 2 is 4, plus 10 root 8, minus 10 root 8, minus 25 root 8 times 8. Okay? Then you start trying to simplify some stuff here, trying to combine like terms. For example, the 15 root 8 and the 2 root 8 we can add together. This piece right here, we have 5 times 8. Sorry, that's an 8, which is 40. And so we can add the 40 and the 6 together and get 46 plus, and then the 15 plus 2 is 17 root 8. And then in turn, the denominator, we can add the 10 root 8 and the negative 10 root 8, and we get 0. And this is minus 25 times 8. 25 times 8 is negative 200, right? And so we have 4 minus 200, which is negative 196. Did you get that, I know? Did you stop there? Is there anything else we could do? Or should we stop there? How about that square root 8? Can we break that down a bit more? And we can, and we need to. Because square root of 8, we got the 4 times 2, 2 times 2. So that's going to be 2 root 2. We have a 17 out in front already. So here's what happens. We end up with 46 plus 17 times 2 root 2 all over negative 196. And then what? Multiply 17 and 2, okay. 46 plus 34 root 2 over negative 196. And then what? See if you could divide them all by something. Look at the 46, the 34, and negative 196. They're all even. So divide them all by 2. So 23, 17, and what's half of 196? 98. Can we reduce more? No. All right. So reduce at that end. And if you could simplify those radicals, simplify them. Okay. Okay, the last part of this is just an application. Again, still doing the same kind of math, but applying it a little bit to geometry. Okay. So here we have a rectangle, and a property of rectangles, opposite sides of rectangles are what? Are congruent to each other. And so if the left side has a length of 4 root 3 minus 2, the right side also has a length of 4 root 3 minus 2. And if the bottom has a length of 5 root 2 plus 7, the top also has that same length. That's a property of a rectangle. And so we need to find two things. We need to find the perimeter. How do you find a perimeter? Add the length of the four sides. So you want to add all four of those up. And then we want to find the area of a rectangle. And how do you find the area of a rectangle? Like length times width. So go ahead and find the perimeter and the area of this rectangle. So here's what you should be getting. Perimeter. You add up all four of them. 4 root 3 plus 4 root 3 plus 5 root... Oh, what did I do wrong? Man, I can't add the 4 and the 5, can I? I need to fix that, don't I? So I can add the 4 root 3 with the 4 root 3 and get 8 root 3. And I can add the 5 root 2 and 5 root 2 and get 10 root 2. And then the negative 2, 7, 7, get positive 10. That looks better, right? And then when you multiply, you don't need like terms. So when you get this expression of 4 terms. Okay. And then the last one is similar to this. They give you the area. They give you one side length, and assume it's a rectangle, okay? And you've got to find this unknown side. Call that side x. So how do you find x? Okay, well, we know x times square root of 11 plus 2 is what? Is the area 7. And so like you said, divide. So x is going to be 7 divided by the square root of 11 plus 2. And that's our answer. But what's wrong is we got a square root in the denominator. And so we need to rationalize that. So any idea what to multiply that by? Good job. You guys are learning something. So you multiply by that to simplify this. And here you go. Okay.